Hey guys, welcome this evening. I know I kind of stand behind you and pizza and beer, so depending on how much questions you have, we are going to divide that by slices. So let's see. Today I'm very proud, so thank you again, that we can show you the Nutanix Kubernetes Platform. Just as a quick overview, right? I know most of you probably know Nutanix and the Nutanix platform as such. And today we are going to talk about this point here. That's the Nutanix Kubernetes Platform and the Nutanix data services for Kubernetes. So probably for some of you which are not aware of what Kubernetes is and what it does, it started as an open source project, and we are trying to containerize applications into it. By that we mean we are able to scale that in a more or less easy way. So it's kind of a Swiss tool knife, right? We have, so you will be efficient, you will be fast if you include that in your DevOps process, and you do have a reduced operative issue in terms of you can push your changes and code fast. What we all see in the daily life of Kubernetes, I'm doing that since Kubernetes is there. There are so much things you need to take care of, right? You're going to scale up your Kubernetes platform, but what about monitoring? What about Grafana? What about Loki? So how do I get my log analysis well done? How do I get my Jenkins pipeline or development pipeline into stream? That's where kind of we come in. We're not going to sell you that at the moment. I'm not a sales guy, I'm a systems engineer. But this is kind of the overview on what we see, what is needed to really provide your customers or your enterprises with a Kubernetes platform or a container platform, right? So everything you see here is kind of mandatory to run that efficiently or in a way that we can say it is trustworthy. What do I mean by trustworthy? If we do not have a cost management in place, or we do not have, for example, Prometheus in place, we are kind of running blind on our Kubernetes platform. We do not have logs, we do not have metrics. Yes, you can do all that by hand in an open source project, because these are all open source projects, right? So you can stick them together and run them. But what happens if Prometheus is going to receive an update and it's not compatible with your Kube CTL, as an example, or Kube API anymore? And this is why Nutanix has now NKP, Nutanix Kubernetes Platform. What we're going to do is we're going to provide you with one single platform, and it is supported from us, right? So you do not have to have 20 engineers, one for Prometheus, one for Kubernetes, one for the server infrastructure. So we are all going to pack that in, and we are going to provide you the support for that. So we are making sure to validate that, test that, release it, and you will get the support from us. What we always see in our world of Kubernetes, and we will go into the deep dive, you do have your infrastructure administration, you do have your platform engineer and your developer, all with different needs. With NKP as such, you can do that with Kubernetes as well, but it is an easy way of separating the infra admin, the platform engineer, and the developer on a role-based access model. Now we're going to think about, you do have your Kubernetes set up. What happens with your developers? Do you really want to have your developers call you in the night at 2 a.m. in the morning? We need to have a fix implemented. Normally, it would be kind of the system engineer or the platform engineer to deploy that patch. So here is why GitOps comes in. GitOps provides you with a way of pushing the code into your repo and have that deployed automatically into your Kubernetes platform. What's kind of different than what we are doing with NKP, so Nutanix Kubernetes Platform, is, as I said, you will get a solution which is all bound together in one solution. You do not have to care about the dependencies, and you can easily integrate your GitOps over APIs. Now talking about Kubernetes, and it's not really related to Nutanix. It's all a common sense if you're going to deploy Kubernetes. What about the design? Now, if you look at your workload, and probably some of you already do have Kubernetes or container environments available, what you can see here is I can either have that as management workload or management cluster, and my management cluster or control plane is controlling my cluster workloads, or I can have that as self-managed cluster. What's the plus and the minus of that? If I'm going to run with that, if that's going to fail, my infrastructure will be gone. Which brings me to high availability on NKP. It's your decision to have kind of, I have two data centers, and I have site A and site B, and I do have a management cluster and workload cluster A and B. That's all fine. So if site A goes down, I still can run site B because I do not need the management cluster, right, on the running infrastructure. I only need that for managing my Kubernetes infrastructure. If we look at an environment where we have 3 sites, we can span the management cluster over all 3 sites, and it doesn't matter if site A goes down or site B. We still do have the management capability. So how it works in a Nutanix way is you do have your bastion host configured, your management cluster with a control plane here, and your worker nodes below. As you can see here, we are all on Kube API. So everything is connected to Kube. What that means is, if you're going to decide, okay, now I do not want to use Nutanix anymore, feel free to move away, because it's all native open source, just controlled. So you can move your workload to any Kubernetes platform you wish. Between here, we are using gRCP as the normal Kubernetes workload does as well. What we at Nutanix try to do is we are always trying to simplify your operations, meaning some of you know that you have kubectl get pods, kube edit, ingress, and so on. We try to simplify that in a way that we are going to provide a cluster API. It's going to allow you to create and manage a cluster And it's also gonna allow you to work on your workload clusters in an easier way than the normal kubelet. How we're going to install that? So this is the way, if you're going to use Nutanix platform or Nutanix NCI, we are going to start with a bootstrap cluster creation. And this is not a process you need to do manually. It's completely automated. So if I think back on my times, I was running around 30, 40 Kubernetes clusters on an open source basis with containerd. I had to do that all by myself manually. With Nutanix, I do have the possibility to have my bootstrap cluster creation. Then we have the API component install. And finally, if you look up here, we are going to destroy the bootstrap cluster completely for you. That's normally manual work you need to do. So in a day-to-day life, it makes your life easier because it's an automated workflow. It's going to provide you with 3 install methods. So normally if you're going to bootstrap Kubernetes cluster, it's kind of a hard thing, right? So you have to install your dependencies, you have to install your container runtime. It's manual work. What we came up with is 3 simple ways of getting your NKP cluster up and running. One is you do have really easy user interface. So you're going to provide some informations to it, and it's going to bootstrap your cluster from scratch. If you're a little bit fancy like me, I want to have control over it. So I'm going to use the CLI for that. What that gives you is more control, especially as an example, if we talk about ingress, right? What ingress engine I'm going to use? Is it Nginx? Is it anything else? Here I do have the possibility to configure that. That's the really advanced one. So as you can see here, we are talking about YAML files. So if you look at the way it is shaped, it's completely a YAML file you're going to deploy. And that's more like your manual process you would normally do in your Kubernetes infrastructure. Talking about private registries. And now this is kind of a question to you. Do you use private registries in your Kubernetes environment or public registries? Does private? Thank you. Good, well done. Does anybody know what's the kind of hazard if you're going to use public registries? What could happen? Yep.
Offline.
Right? Software?
Or the repo can just vanish. They could remove old versions which you need.
Yep. But could it also be that you will have a security issue with using public registry? You don't know, right? No, never. You don't know. So the public registries are kind of untrustworthy, right? In a sense that you never know if you do have a code inject somewhere, right? Or there is a library used that is vulnerable for your environment. This is why we are always, at least in the enterprise environment, we go with private registries. That, and if you do have an air-capped system, which means your Kubernetes services do not have access to the outside world, you will not be able to do a Helm install, as example, from a public registry. So what is it? As you can read, It's the same as a public registry, but it's running inside your infrastructure and you have the control over it. And here we have all the answers, right? So network bandwidth, all right, not that much of an issue, right? But it is controlled access. So if you're going to pull a Helm image or a Helm chart from a public repo, you do not know what it's going to do. Unless you're going to really be sure and examining every step it is doing. So you're going to download it to your private image. You make sure you're going to run your security scan. And then you're going to deploy it. As well as for air-capped customers. Air-capped customers are always customers which will not allow you to have any internet access whatsoever. So you need to have your private ray. These are basically, pick an image registry of your choice. I like Harbor a lot, but basically we are open to anything you are going to use right now or you're going to choose. Right. What we are going to provide you with is we deployed our application. We do have, let's say, 5-6 pods, 8 worker nodes, and so on. Now what's about the metrics? Built in, we are going to provide you with Grafana Prometheus, which allows you automatically to get your metrics, logs, and reports. We also do have Loki. So if you know about Loki, we are getting the logs out of your applications. How many workers do I need? That's always a question, and I just want to give that to you as some kind of guidance, right? You do have developers in your company. They will not tell you because they don't know. As simple as that. So we have two things. One is a resource request in Kubernetes or in the container world, and the other thing is a resource limit. A resource request is always something, if you're going to spin up a pod, it's going to grab that resources from you, right? So please be aware that as soon as you do have your resource request set, it will grab that resources and your resource limits. So if you are an engineer like me, running Tomcat, for example, in such environments, it's going to hit the resource limit anyway. So it's going to end on a crash loop, OOM killed. What does that mean in a technical term? We limited the pods or the deployment to the specific limit we set. And Tomcat, as an example, garbage collection, lot of requests, it will be killed. So one thing I can give you with that, if you see that, it's probably because it is going to hit the resource or it hit the resource limit. So you want to either increase the limit, which I cannot approve, or talk to your developers to check the application that it is running on. So in conclusion, right, you see that it's not only a workload consideration. It's customer workloads you're going to run on. It is your Kubernetes tooling that needs to be set up right. Your Kubernetes core and the Node OS. So everything needs to be considered if you're going to run a workload on Kubernetes. And here you can see again, ideally, what do we need, right? We need to have resource requests. That's my minimum consumption. Where do I get that from? Probably from the development or in our lab experiment. So if you're going to run that on our lab, we know. And again, tool loading. Please make sure if we quantified our workload needs, we need to make sure to add our tooling on top of it. And again, this goes down to the whole core workload we need, right? We can vary with the node numbers, but basically, if you're going to plan and size your Kubernetes workload, whether it is on Nutanix or on any Kubernetes services, make sure to take that into consideration. Comes down to the equation of less big workers or more small workers. And that's up to you, right? So if you do have a worker node which is big and it's going to fail completely. And it also may cause resource wasting. More small workers, meaning you do have more worker nodes as such, it's more OS overhead. Simple as that. So that comes down to the decision that you need to make with the application you're going to deploy. Last but not least, right, what we have here is, if you look at that, we do have our Grafana in place. And if you can see now here, we see a control plane issue that started here. So we do have all the information and all the metrics available for you to really operate your Kubernetes environment in an efficient way and make sure that you have your customers served. With that, I'm already over time. Any questions? That was a deep dive, huh? No pizza slices for you then. All right. Thank you so much.